Well, hello everyone, and welcome to What It Takes to Build a Skyscraper in New York City, a special live event brought to you by the B1M in partnership with Autodesk Construction Cloud. I'm Fred Mills, I'm the founder of the B1M, and for those of you that have been watching the B1M over the years, you'll know that we certainly like a New York skyscraper or two. So today's topic is something I'm really looking forward to. Thankfully, I'm joined by some actual proper New York skyscraper experts today, and we're going to meet them in just a moment. Just to give a bit of an outline of the agenda today, we're going to run for about 60 minutes. I'm going to start with introducing our panelists. We'll then talk a little bit about the context of building skyscrapers in New York City. We're then going to hear from Autodesk. We're then going to go into detail with our panel and ask them some kind of pre-prepared questions on the nuts and bolts, if you pardon the pun, about how you actually make skyscrapers happen in this city. And then we want to hear from you guys. We want to answer as many of your questions as we can. So do get them coming in the Q&A feature on Zoom. There's two features, there's chat and there's Q&A. Try and get your questions into Q&A, try and keep your chat in the chat. You won't do that, but we'll try, and I'll say it at the start of the Zoom webinar anyway, and we'll see what happens. But that's good, so we'll get going from there. So let's meet this expert panel I spoke about. Here they are, fantastic group of people. First of all, Stephen Bradbury, you're joining us from Perry Formwork Systems. Can you give us a bit of background on who you are and what you do?
Okay, yeah, so right now I'm the regional sales manager for our building division in Perry, Northeast US. So my market, we cover New York, New Jersey, up to the Boston market. Prior to that, I was in technical sales in Canada. I started with the company about 22 years ago as a designer in our Boston office. So this is almost my second job right out of college, and Perry's been where I've been pretty much most of my working life.
Awesome, it's great to have you with us. And Jeff, you're joining us from the Walsh Group.
Hi, Jeff Twidwell. Yep, I'm a senior project manager with Walsh Construction, and I'm currently in New York City serving as our project executive for the $4 billion LaGuardia Airport redevelopment.
Fantastic. Thanks for being with us, Jeff. Rachel's joining us from Autodesk.
Yeah, hey everyone. My name is Rachel Trochi. I'm a technical solutions executive on the Autodesk construction team. So in my role, I kind of work more as a technical specialist on the product side of the house, but I do come from industry, so my background's in civil engineering, and came to Autodesk through an acquisition over the many that they've completed over the past couple of years. So really excited to be here and work with a ton of different contractors across the board within New York City, again, pretty close by, based out of Boston. But yeah, excited to kind of be here and talk with everyone today.
Awesome. Yeah, it's great to have you with us, Rachel. It's the software that underpins so much of what we do in this industry. So yeah, it's great to have you with us. And last but by no means least, we're very privileged to have Stephen DeSimone of DeSimone Consulting Engineers with us. Stephen, can you introduce yourself and give us a bit of background on where you're coming from?
Sure, absolutely. Yeah, my name's Stephen DeSimone. I'm the president and CEO of DeSimone Consulting Engineers. We're headquartered here in New York. We've got offices around the country. We're probably working on 30 or 40 high-rise buildings in about 15 states around the country. So we've got a pretty broad view of the market and of the practice. I'm a big skyscraper enthusiast. I'm also a board member of the Skyscraper Museum as well. So, we love them tall. Buildings can never be too tall, so.
Oh man, well, it's fantastic to have such an expert panel with us. I'm feeling a little bit less nervous now because I know I've got the experts in the room that I can lean upon. So it's good to have you all here. Thanks for making the time. First of all, then, a little bit of context for those of you who need an introduction. This is Manhattan in New York. It doesn't really need an introduction. It's a world-class city. It's the city that never sleeps. We're very conscious that New York is several boroughs. I'm painfully aware this is just Manhattan. So for those of you tuning in from Queens, Brooklyn, or elsewhere, we see you, we hear you, we love your support. Today we are going to be talking largely about Manhattan because this is where many of these challenges kind of manifest themselves. It's where the tallest buildings are, it's where space is tightest, it's where restrictions are tightest. So that's where our focus is going to be today. But building a skyscraper in New York is very different to building one anywhere else in the world. There's not just the pressure of adding an incredible building to the world's most famous skyline. I don't think many people would dispute it is the world's most famous skyline. But there's all kinds of things you have to think about that you wouldn't have to think about in other cities. And we're going to give you a bit of a brief overview of some of those things right now. First being shipping and wide load permits. Jeff's going to tell us in a moment about some of the complexities of bringing plant and machinery onto Manhattan Island. But this is an incredibly complex area. You have to request permits days in advance for a single day. You've then got to make sure on that day that you can get to site, whether that's the traffic or the weather or the site delays, anything like that. So it puts quite a lot of pressure on and makes it quite a tricky logistical feat to manage. Jeff has got some fantastic anecdotes about times of day where lorries need to be when, which we're going to hear about in just a moment. This picture from Perry, I think, really speaks to the challenge. This is a Perry truck that's parked up outside a site, a wide load. You can see this is a big piece of kit. It's a big piece of machinery in the middle of one of the world's busiest and most congested cities. So this is not easy, and it's something that has to be really cleverly thought about and planned through. One of the big things we're going to be talking about today is steel frame before concrete core. Now, I'm conscious that if you're not watching this in New York, if you're watching this from somewhere else in the world, the idea of putting a steel frame up before the concrete core kind of feels, I mean, to be honest, it kind of feels like madness. But it's something that does happen in New York. It's not on every skyscraper. It's about 50-50, but it's something that you do encounter in New York. It's kind of driven by the ironworkers and the ironworkers unions who don't like working without some kind of overhead protection above them. And that's created some challenges and some issues, as we're going to hear later on today. Big example is One Vanderbilt, one of the biggest and tallest new skyscrapers to recently complete in New York. This was a Perry project. You can see in the photo on the left there, that is a classic example of a steel frame rising before a concrete core. I want to give a big shout out to the guys at Field Condition who do amazing photography of New York and beyond, all the stuff that's going on there. So thanks guys for this photo, it's awesome. This speaks to the challenges. This is a classic example of a major skyscraper with, as I said, steel rising before the concrete core. It's almost such a done thing in New York that when the other way is done, when we build a core first followed by steel, it almost becomes something of a novelty, certainly to our friends in publishing at the at the New York Times, who did this rather novel article about a skyscraper being built from the inside out because its core was going up before steel. I also found this really interesting piece in BDC, again, highlighting the fact that a core first approach had saved time and money on a New York high-rise project, as if it's something kind of innovative, but we'll talk about that a little bit later on in some more detail. I want to bring in Stephen Bradbury from Perry here, because Stephen, I think it's useful for people to understand before we get to the complexities of how you build a concrete core after a steel frame. It's useful to understand how you would normally build it with a Perry ACS 400 jump core system. So are you okay if I play this video just to kind of talk us through what's happening and how the system works?
Yeah, sure, no problem, go for it. So here we see the first core being made with our Vario panels that the concrete struck, and now we're installing the internal hydraulics. And typically this is what's lifting the entire interior and outside formwork. So everything's climbed from the inside of the core, including the exterior forms, which are large panels to minimize the amount of labor, to minimize the amount of assembly. So in a normal application, this is what we're seeing. And you see the green rams. These are our hydraulic pistons that are anchored into the inside wall formwork. So we push up off the precast anchors, the casted place anchors. Another live photo of a project, and it's all being climbed from the inside. The outside is being hung on our gallows systems, so everything is connected and driven by the inside platforms. And this is what we would see in a typical core job, and how we would like to do it on every job if possible.
Fantastic. That's a really good explanation. You can see it's incredibly slick and well-perfected system. It is complicated, but it's very slick. It works very well on a number of skyscraper projects.
And once it's in place, it requires very little amount of labor to keep it going up. You know, some guys to strip ties and run the machines but everything, all the hard work is done in the installation, if it is hard, and then the next step is get it off the building at the end of the job.
Definitely. As you can see, that's the kind of conventional system. I think for anyone watching that's thinking, surely putting up a steel frame followed by a concrete floor is complicated. You're right, it is complicated. I think this picture kind of sums up everything about the complexity. So we'll come back to it a little bit later on, Stephen, but this really sums up what you're up against with building a concrete core after a steel frame, isn't it?
100%.
Yeah, sure. We'll talk about it a little bit later on. Next thing is concrete pouring. So often the concrete slabs and verticals we poured at the same time, where you have a fully cast in situ concrete building. So forget steel frame construction, full cast in situ concrete building. You tend to pour the verticals and slabs at the same time in New York, which comes down to time and to speed, and helps construction teams really get to that 3-day cycle. So every 3 days they're moving up onto the next story of the building, and that's how quickly these buildings can rise on the skyline. Again, we're going to hear a little bit more about that a little bit later on from Stephen at D. Simone. Now, last but not least, the Department of Building Approvals, which I know Stephen Bradbury from Perry is very familiar with. This is a kind of a special body that, well, it's just certainly in New York City, that has to verify and check concrete jump core systems. So the kind of systems we just saw in that video, they have to be verified, checked, and reviewed independently before works can progress on site by this body. That adds time, it adds a bit of bureaucracy, and you have to make sure you get your design and proposals in quite early in the project, even when the project's kind of still being designed. So again, another aspect that comes with putting a skyscraper up in New York that many people maybe have not appreciated, but that Stephen's going to walk us through a little bit later on in some detail. Now, before we go into the panel discussion, before we hear in detail from our panelists about how on earth they navigate all those challenges to build some of the world's tallest buildings, we're going to hear from Autodesk Construction Cloud, and Rachel is going to talk to us about Autodesk Takeoff and how that software is really enabling some of these incredible buildings to be built. So Rachel, over to you.
Awesome. Yeah, thanks, Fred. So as we kind of dive in here and we jump into, the Autodesk Takeoff solution itself here, what you're going to see is that this is going to really enable your teams to quickly and efficiently get through that quantity takeoff process. So if you're not familiar, Autodesk Takeoff is actually one of the newest solutions to market here within the Autodesk Construction Cloud umbrella. And what it's doing is it's leveraging a cloud-based solution to bring together our 2D quantity takeoff workflows as well as our 3D quantity takeoff workflows. So as we kind of just dive right into the solution here and kind of walk through this little video here of the tool, what you're going to initially see is that on this home page here, you're going to have access to quickly jump right into any recent sheets and models that you might have been working off of. Because it's that cloud-based platform, you can quickly jump right in. All you need is that Wi-Fi connection, and then we can also jump into any of those recent takeoff packages or anything like that as well. But what's really important about Autodesk Takeoff and about kind of this cloud-based solution is that it's leveraged on top of the Autodesk Construction Cloud Unified Platform. So we're leveraging Autodesk Docs as kind of that central common data environment throughout these different modules of that full project lifecycle. So obviously Takeoff fits a little bit more into kind of that pre-construction planning phase here, but different than a lot of the different desktop-based solutions, we're going to have access to this robust, common data environment here. So we don't have to worry about everyone locally downloading this information, opening it up on their desktops. They can access this information directly in here within the cloud-based environment. And once we have access to all of our project files in here, we can push that right over into our Sheets and Models tab to kind of kickstart that takeoff process there. And again, because it's a collaborative cloud-based environment, not every estimator needs to do that themselves. Just one person can set that project up, and now everyone can access this information here.
With the panelists.
So coming to kind of initially start that takeoff process, if we jump over into that packages tab here, we're going to have the ability to create any takeoff package that we might want to. So these can be broken down by scope, maybe by location of the project, maybe by different estimators, however you want to manage it throughout that full project life cycle. And then from here, you're going to see you have all that information for your sheets and models, everything that you traditionally would need for that takeoff process. And so just to kind of dive in specifically into that 2D workflow here, very standard to your traditional quantity takeoff process here, but as you drive in, you have that collaborative environment. You can see any recent takeoffs you've made or any other takeoffs that might be in here within this specific package that another estimator on your team might have created. So just kind of walk through, we'll do a quick little sample here of a wall takeoff. As we jump in, we can give it a type name right here. Then we're going to define out what tool type. Obviously, you have your standard area, linear, count, and then we have that BIM tool type, which we'll touch on in a minute. But for our wall takeoff here, we'll go ahead and we'll grab that linear tool type. We can add in a description, adjust the colorization, and then we're going to actually define this under a cost code. These cost coding structures are completely customizable. You guys can upload in whatever cost coding structure you might want to be using. So if you have anything that's tweaked to your specific company, you can leverage that. And then we'll provide in, based off of this tool type right here of linear, we'll provide in that default height for our wall to get that total square footage once we actually create that calculation. So walking through, we have your kind of traditional snap to points here. And now you kind of walk through and create that little takeoff item for a wall. Once you do that, you're going to see as you double click and get rid of that takeoff right there for that wall, you can see you have your quantities right over there on the left-hand side. They're automatically aggregating, and they'll ultimately be aggregated down within an inventory as well amongst our 3D quantities too. So coming in here, you can adjust that takeoff type. You can add vertices if it's a curved wall, whatever it might need. And then of course, just like I was saying, that's all going to aggregate down within the inventory. But before we kind of jump into that full final quantity view, I want to walk through a little bit of what that 3D takeoff is going to look like. And so 3D takeoffs is something that, is starting to slowly get out there within the industry. But what it's really going to allow you guys is a ton of efficiency. So especially on some of these really large New York City skyscraper projects that we have, being able to leverage that 3D model and leverage that information there can streamline efficiencies throughout the entire project, but also through that quantity takeoff and pre-construction process. So just for a quick door takeoff example, if I right click, you can select all of those different doors in here. And now, rather than coming in and selecting every single door within each drawing that you have within each floor plan of the project, and we know, on a skyscraper project, there's a lot of floor plans, you'll be able to now quickly jump in, associate that door takeoff type right here to a cost code. And now right away, if we just come in and we'll hit start takeoff, it'll automatically pull out every single door of that same type. And all you have to do is hit that check mark. And now you'll see that that door has now been colorized and it's been taken off. So really quick and easy to start to aggregate all of that information right there from that 3D side of things and combine that together with the 2D piece here. A couple other pieces within the 3D, you have different filtering capabilities. So it's going to give estimators a lot more visibility and understanding into the project. And we have our form clusters command right here, which is going to quickly allow estimators to understand in their kind of typical project understanding initially earlier on where all the different items are within the project. So we can break things down into different categories. You can see we have all of our doors here. We see all those red ones have been taken off, but those gray ones haven't yet. So now if we pop right back into the model, we can see exactly where that door was that we just had over there in the clusters. So a lot of different really great capabilities here within Autodesk Takeoff. And, to kind of round all of this out right here within that 3D and that 2D takeoff process, it's all going to ultimately connect into that final takeoff report to then be ultimately pushed over into your estimate. So you can see down in here, you have all your different quantities for your takeoff items. You can filter and organize your quantities however you need to. So based off of different takeoff type, maybe it's based off of those cost codes that you have in there. And then of course you can report out this information. So just coming right over into the export, we can push it right down into Excel. I know a ton of estimators are still in Excel on their typical day-to-day. So we can go ahead, export that information right to Excel, or you can push that right over into maybe Sage or whatever other estimating solution you're typically using. So that's kind of a quick overview here of Autodesk Takeoff in general. And again, just to kind of highlight some of those key points there is being able to leverage that 3D model for when you actually have access to a 3D model, if you're working on a really large project or a design build and you have that capability to get in there early with the model, it's hugely powerful, hugely beneficial to really streamline some of those efficiencies. And, you know, just like we'll talk about, there's going to be a lot of potential schedule delays throughout the course of the project. So being able to streamline some of those efficiencies early on can be really impactful. So yeah, that's a quick overview of Autodesk Takeoff, and hopefully you guys definitely see some of the value here.
Awesome, thank you, Rachel. That was that's fantastic. I think as anyone watching knows, getting your hands on the right data, particularly when it comes to cost, is absolutely priceless. So that looks like a fantastic tool. Thanks for taking us through it. Now, even though Rachel's demonstration was awesome, if you would like a personalized demonstration, you can get one from Autodesk. They're very kindly giving them out for free. There is a poll we're going to be running, which I'm just about to launch right now. If you just respond to that poll, yes or no, if you respond yes, Autodesk will contact you to arrange a free demonstration. If you respond no, they will leave you alone and not darken your door again. We're going to leave that poll running throughout the session, so do vote yes or no on that if you can as we go through. That would be fantastic. Also, don't forget, we're going to answer your questions, so get as many of those coming into that Q&A feature on Zoom as you possibly can. That would be great. We'll get through them in a moment. Now, back to the expert panel. One moment. There we go, wonders of Zoom. Back to our expert panel. I want to hear from from Jeff, first of all, talking about shipping and wide load permits. Jeff, you've done plenty of projects in New York and particularly in Manhattan. As we know, it's the city that never sleeps. There's never a quiet moment. How do you go about getting construction plant and material onto site in this city, and what are some of the lengths that you've had to go to over the years?
Sure. Yeah, it's you know, as you can see from the brief introduction you gave, there's multiple constraints that you're working under. So you know, construction and logistics in New York City is all about pre-planning and really precision in balancing those multiple constraints. So for wide load permits specifically, generally you're having to get a permit for a specific tractor trailer combination for a specific delivery on a specific day. And it takes about 3 days to get those permits. So you're not able to really change on the fly. You're having to plan multiple days in advance to sequence your material deliveries to site. So, you know, we recently were building a large precast structure. We had about 3,000 precast members, each individually shipped under these wide load permits. So our precaster was based in Pennsylvania and had to travel through New Jersey and across the George Washington Bridge, which is one of the main arteries into Manhattan. So we were actually balancing competing constraints from New Jersey and the George Washington Bridge. In New Jersey, you can't have wide loads on the road after nightfall, whereas the George Washington Bridge will not allow a wide load until 10 p.m. So we were basically each day, you know, we'd have trucks that would travel through the day in New Jersey. We had to find space for them to stage right near the George Washington Bridge at night, and then make the trip over, you know, once it hit 10 o'clock. So, you know, the challenges are they kind of compound, because then you've now brought materials into the city overnight, except you've got, you know, noise restrictions on when you can do certain work in the city. So you're generally then, once you get into Manhattan, you're still having to, you know, either if you're lucky enough to have a laydown yard where you can store your materials, you can take it there. Otherwise, you know, you're generally having to stage your trucks again, waiting for the start of the shift at 7 a.m. And bringing them to site. So, you know, especially in the high-rise projects in the really dense parts of Manhattan, you don't have space to shake out your materials. You're delivering your you know, steel or whatever whatever large loads to site, and then direct picking off the truck and erecting them. So it is a delicate ballet, but you're competing with extremely congested traffic, with millions of people that live in the city and don't want to hear you constructing a building, and and a lot of really big materials. So it's a delicate balance.
Definitely. I mean, it sounds like there's not a lot of room for kind of spontaneity. You can't decide we're going to do this today, because you have to have planned it days in advance. And I guess, if something doesn't happen one day, or the weather's bad, or things get delayed slightly, that can have a huge knock-on effect with these kind of logistics.
Yep, and it adds to the cost of construction. I mean, people are always shocked when they come to New York and see what it costs to build here, and that's a big part of it.
Absolutely. I mean, Stephen from Perry, what's kind of been your take on this? Because you're bringing these, they're not small formwork climbing systems into the city to go on the bottom of skyscrapers and then taking them out again. How have you found this challenge?
No, it's exactly what Jeff was just speaking to. The same types of constraints. You're called in. The guys are at the bridge. You show up at 5 in the morning on the site to offload, and you really got to think about this as like airplanes landing in an airport. You have a set window, a set gate, and a set time. And what you just mentioned, something comes up, you have like 5 or 10 minutes, maybe an hour to hang out, and then a decision is made. It's not going to happen today. Get this truck out of here. And because you have 4 other trucks behind that need to get offloaded. And so from our side, when we're working with our concrete subcontractors, they have to work with the general contractors and all the other trades, because there's tons of steel coming in here at the same time too, and concrete, and everybody's pressed for space. There's absolutely no room on the sites to store material. So decisions could be made, okay, push this off, and these costs start incurring, because these wide load trucks are not cheap to bring in, over the roads. They could be anywhere between, say, $4,000 to $7,000 per truck for a one-way trip, because they're wide loads. So that's a lot of trucks. If you have 3,000 loads, you could do the math, and the costs are gonna ramp up, plus the delays. And also the fact that since there is no laydown space anywhere, the amount of effort our logistics people go through with dealing with the subcontractors on site and the trucking companies to make that ballet, as Jeff just said, work out properly. It's amazing that we get anything done on time, but it does happen. People do great work. There's a lot of angry phone calls, but also good phone calls. I think my first experience in Manhattan driving down the street was behind one of these tractor trailers. And I said, this has to be the worst job in the world, making a delivery of that size in Manhattan, because, you make a wrong turn and you have to drive for blocks and blocks to make that delivery. So it's a lot of effort, and it does add a significant amount of planning and cost to the project. So it have to come off right.
Definitely. I love the kind of the ballet analogy, because people like ballet and construction are like completely different ends of the spectrum, but it speaks to just how carefully planned and delicate the whole thing is. It's not as rough and ready as perhaps people think it is. Stephen, staying with you from Perry, sorry, Stephen, because we've got 2 Stephens, so Stephen from Perry, Stephen Bradbury. Going on to this challenge about building a steel frame before a concrete core. I know you guys were doing that at One Vanderbilt, which we spoke about. We've spoken about why New York does that, and we know it's driven by iron workers and some of the kind of the union approach, but how on earth do you go about it? That photo we saw was extraordinarily complex. You specialize in the New York area. How it's not just alien to people, it's alien to some of probably Perry's teams as well, who work on skyscrapers around the world. How do you approach this? How do you pull that off?
Well, I mean, first off, hats off to our clients who actually execute the work. We sort of give them the plans and the material and advise them, but they're the guys and girls that are rolling their sleeves and doing it. So Novelist in this case did an excellent job. It's a lot of pre-planning, a lot of meetings, a lot of sacrifice on the efficiencies of the form system, because now, if we remember back to the intro where we're seeing our Core 400 system climb, The inside formwork changes a little bit because there's a lot of structural steel in the way, and also the fact that we have to assemble it in smaller pieces to fish our way through all of that structural steel that's in place. You got to remember that when we show up on this site, all of the steel is in front of us, and we don't have any crane access, or it's very limited. So the form or the kit that might have been assembled in one large unit and installed in place, saving time and money, now has to be installed in 5 pieces. So that's 5 extra picks of the crane. Those may need to be pre-assembled somewhere on the site because just the way it is. And the other thing about it is now the exterior formwork, which is not climbing with our core climber, all has to be set by hand because there's no access whatsoever. So this brings in, typically the form costs are going to be a little bit higher. Patching to the concrete face is going to increase because you now have more seams, and the amount of labor that's going to be required is going to go through the roof. You're going from 4 to 5 people on a small core that could manage the whole formwork that's climbing with the system. Now you're going to bring in 10 times as many guys to hand set everything to keep that schedule. So that adds a lot of complexity and potential. Everything goes up every time someone touches something. There's a risk for safety issue, people getting hurt, and just the volume as a material that they have to hand pass up through these buildings. On one Vanderbilt, some of these walls were 20 feet high, so they strip it down, pour up again. So everything's going up floor by floor by floor. So it's a lot of extra work having the steel in front of us in terms of sacrificing the efficiency of a concrete core system.
See. I mean, Stephen from D. Simone, what's your perspective from a design side? I mean, from an engineering perspective, how is designing one of these skyscrapers different to designing a skyscraper that's going to be built conventionally? And by that, I mean the core before the steel frame.
Well, yeah, I mean, I think it's look, I always think structure and the approach to structure is really market driven, and I'm sure Stephen can speak to this, right? It's, you've got contractors in New York who advance the core first with steel follow on, and then you've got others that prefer to advance the steel first with the concrete follow on. So it really is dependent on who ultimately is going to build it, and I think that's where as engineers, as designers, we've got to spend a lot of time listening as opposed to talking, and tailoring the design accordingly. Right? It's a different approach to advance the concrete core first and follow on steel than advance the steel and then follow on with concrete. So different nuances to each, but ultimately it's about what's going to get you. When you think about the critical path on a project, it's all about the core, right? So getting the elevator core complete and enclosed so that elevator work can progress is really important. And so something that we actually focus on when we're looking at schedule and approach to a project. So yeah, I think it's really market driven. I think, and again, as engineers and designers, we've got to be cognizant of that. We've got to be willing to listen.
Definitely. I guess one question I had, and I appreciate it might vary on different building to building, but how far can you progress a steel frame ahead before you really need to have the concrete core kind of there to give it that central stability?
Well, I mean, that's interesting, right? Because, if you think about, when you look at the image of one Vanderbilt, and we were not the engineers on that, by the way, there's steel bracing in place. So I'm sure there's a calculation that was done to say, hey, how far are we going to advance the steel frame ahead of the core? And what does that supplemental bracing that's in place prior to the core being formed, what does that look like? And what are the loads that need to be resisted? Generally speaking, when you advance a concrete core first, I mean, the core itself is really self-supporting. And you would never do it, but you could advance a concrete core 40, 50 stories before any of the structural steel is ultimately erected and attached. So different approaches.
No, definitely. I'm certainly sitting here in London. I I've seen many of our buildings rise, and they always rise with the core first, and the steel follows maybe up to 10 stories behind max. But buildings like the Shards, 22 Bishopsgate have, I've sort of studied them from the office window, doing that over time. So definitely. Staying with you, Stephen, if we can, because I want to talk about now the poured in situ concrete frames, because there's an approach in New York of pouring the slabs and the verticals together. Can you speak a bit more about why that's done, and again, some of the challenges that might present from an engineering perspective?
Yeah, I mean, absolutely. So I think, like, more and more we're seeing, look, in markets like DC and South Florida, a lot of our commercial buildings are all concrete. Here in New York, we're seeing more and more of that. Generally speaking, on any all concrete project in New York, because we're a very high labor rate town, and Jeff and Stephen were talking to that previously, the speed is really the driver of cost. So to the extent that we can minimize labor, we do so. So typically on projects, depending on the floor plate size, we're doing a floor every 2 days or a floor every 3 days, right? So what does that mean just in terms of sequence, right? Day one, you're standing up forms, all your verticals, columns, and walls. And then you're actually reforming the slabs as well. So we don't really have the luxury, given the tight time frame, to form and pour verticals, strip the forms, and then form and pour the flat work. Also, New York's really tight. Jeff was talking to that before. Mid-block sites, the streets are narrow. Normally, where we would use table forms to form the slabs, we're really using stick built, right? So it's 4x4s with plywood, tight sites. You don't have the ability to really lift and pick over streets. So that dictates a lot of the form solutions that we can use. But yeah, it's really about speed. So to the extent that we can even modify our designs to simplify the construction, we do that. So again, day one, you're standing up verticals. End of day one, you might be even pouring verticals. And what having them both in place does, in addition to giving you a working platform, right, it gives the contractor the ability to pour at will. So if they're a little ahead on day one, they can start pouring verticals. Day two is a combination of verticals and flat work, with a finish on day three if it's a 3-day cycle. So it's really about flexibility and speed, and not really kind of this very linear approach where you're standing columns up, forming, pouring, stripping, and then starting your flat work. So again, it's really in a market that's really driven by labor. The ability to move quickly is absolutely key.
Absolutely. No, I think that the saying that time is money is never clearer than in construction.
Absolutely. And when you look at a concrete operation, Stephen can talk to this on all concrete projects. You're talking 75, 80 men and women on a deck. It's really very orchestrated. Everybody has a role and a job, but if you've done a project where you're budgeting 3 days per floor and you go over, there's no 3.5 day, it becomes another day of manpower. So the penalties for the contractor are pretty stiff.
Absolutely. Stephen Bradbury from Perry, coming back to this NYC Department of Buildings Approval thing, which I know is a particular nuance for jump core systems in the city. Can you speak about, I guess, what's involved in that process? What kind of challenges does it present? But also, the question I have is how do you do that so early in the process when the building design might not be fully finalized yet?
Well, we really need to have our issue for construction drawings prepared and done and sealed before we even tender anything to DOB, because they may not even want to consider it. So we're starting to design as soon as we can, because this typically the process for them to review it is going to be 3 to 4 weeks, depending on their backlog. And if there's a lot of projects that are on the go, and it is an office, it's a government agency, things start piling up on people's desk. And in the case of One Vanderbilt, the turnaround time, I believe, was about 8 weeks after we submitted our package. So Um, and this was a complete Perry design that was sealed by New York State PE, and then they then take it in hand and start examining it line by line to make sure everything is 100%, and they can sign off on it, return to us, and say, okay, now you can start doing your thing. We're able to get a jump on some of the construction as far as pre-assembling of our units that we know that's maybe not going to change so much. If anything did change dramatically, to make sure that we're on top of the schedule. But if there was a change in the building structure, that was really that dramatic, and we couldn't isolate it, you'd almost have to start from scratch again. So if you had to get in the back of the end of the line again and put another 4 more weeks on a schedule when you're supposed to deliver, next month, that would add a tremendous amount of cost. They do have, you can get apply for expediting services and things like that for any changes that you have to make. But for sure, it does add a little bit of complexity into the whole package review, as well as after the job is on the go, the DOB can come by if they see something they don't like. They're offering shutting things down and say, we need this addressed, and the job is at a standstill until this gets fixed. And it could be something that's very minor, could be a serious issue that they want to address too, but you're really at their mercy to make sure everything is set in stone and as per your drawings. And it requires a fair amount of diligence on our clients' part to make sure they're doing everything right. And they know that, because the last thing they want is to be shut down by DOB, because any delay, it's all about the dollars. So
really, all comes back to money, as we're finding, on this chat. Definitely. We're going to move on to some of your questions now, guys. So do keep them coming into the Q&A feature on Zoom. We've got lots coming in already. Also, do complete the Autodesk poll if you haven't done it already. We've had, I think, record response to the poll. So if you haven't done it yet, you're being left out and you're not part of the club. So join in and make sure you complete the poll. First of all, some questions from the audience now. So first of all, this one comes from Christian, who asks that most sites I've been on have job trailers for management to work in or have meetings. Is there space for that in New York City and particularly in Manhattan? And if not, where do the management teams work?
Yeah, I can take that. So generally, a lot of sites you're not going to have kind of a freestanding space for trailers. Sometimes if you can get a permanent lane closure on the road, you can park a trailer, but for super tall towers, we're going to utilize the building itself as it comes up. So the first few floors, and then really as the building's rising, we also have to have Connex boxes and space for the craft, their materials and break spaces. And so I think the focus is as you rise up in the building, it's getting the craft areas as close to their work as possible. As you can imagine, if you're 50 stories up and you're trying to take a lunch break, it takes a while to get down those 50 stories in a hoist. So you're trying to move up with the building, and the trades kind of follow their work.
Absolutely. Another question we've had come in. This is kind of again about material distribution. Can materials be brought to Manhattan by barge on the river, and would there be any advantages to doing that, recognizing there's still some distance to go between the piers and a high-rise construction site? But is that a way of getting materials in potentially?
Sure. Yeah, that it absolutely is, and sometimes it's the only way of getting materials in. There's loads that are just too big to make it across the George Washington. It's not one of my jobs, but I know a colleague who had a job on the west side of Manhattan, where they had a load so large. I mean, you still have the constraint, like you said, of getting from the barge to the job site. They had to basically get a special permit from the Department of Buildings to utilize the road, and they had to remove the mast from the light poles just to get the load to site, and then restore them before the morning people wake up and start using the street again. So it creates its own challenges. The other issue with barging is it's just, it's a lot more expensive. If you can get something on a truck, that's what we generally want to do, but sometimes you can't.
We've had another question from Gabriel, who's asked about the trend of super slender buildings that's emerging in Manhattan. You know, a lot of the likes of 432 Park Avenue, 111 W57, even Central Park Tower, I believe, falls into that category. Gabriel's asked where you guys see that trend heading, but I maybe adapt that a little bit and say, are there any kind of particular challenges that you've encountered or that you think are encountered on those kind of projects as opposed to kind of stockier buildings like One Vanderbilt, I imagine?
Yeah, I'll start on that one, right? So yeah, I mean, look, taller is better. Taller is also way more expensive, right? The costs are really non-linear at that point. Look, the greatest challenges for us really are in material strengths, number one. How do we get, higher strength concrete, but more importantly, we're looking for high modulus concrete. And that is really a super challenge for us. Additionally, look, wind and perception of motion and aerodynamics are super key at that point, right? I mean, the buildings that we're doing at those heights are really influenced by the wind. Look, all buildings move. It's really the nature of the movement that we're most concerned about, right? Do people perceive the motion of a tall tower or not? We're using advanced wind tunnel analyses to do and evaluate that. We're incorporating damping devices at the roof to minimize that. But what we're also seeing is, a lot of the other trades really haven't caught up. There are instances where you've got partitions or squeaking and air leaks. So it's these sort of audio cues that really have nothing to do with building movement that lead people to believe that the building is moving and it makes them uncomfortable, right? So those are the kind of some of the challenges that we're facing. Look, the engineering, I think we know how to do it. We've monitored a lot of the tall buildings that we've done previously, really to confirm whether or not the assumptions that we made are accurate. And for the most part, they are. So it's really then dealing with, sort of the next level is dealing with those other challenges. Again, I mentioned partitions. Elevator performance is another big issue. Stack effect, right? That effect that's created by, hot air, warmed air, moving vertically through elevator shafts, and what impact that has on elevator performance. Certain buildings have doors that slam shut, right? So there's a lot of kind of non-structural things that we're confronted with on these buildings. But again, when you're the first, even when you're the second, it takes a while for all of this to shake out. So look, I think the future is always bright for high-rise buildings, in addition to them, being symbols of the aspirations of a city, they're economic drivers, right? I mean, you look at the cost to build and then the resulting sales. Some of our super talls in New York, they're getting north of $10,000 a square foot on sales price. So for all of the premium that we paid to get that high, there's a real exclusivity to being able to say that I live on the 88th floor of a super luxury building. So they're here to stay for sure.
Definitely, we've seen the views from those buildings. It's some remarkable scenery of what, as I said earlier, is the best, most iconic skyline in the world. So
yep, just to say you're there is really all right. A lot of it's ego driven too. So
completely. Thomas has asked a really great question, and I guess this is quite interesting. He says, what considerations have to be made during foundation construction? What if buildings sit above services or underground railway lines? I guess we've spoken a lot here about building up and the challenges of building up, but to build up, you have to go down a bit first. So it's one of the most congested, busiest islands in the world. There's all sorts going on below the ground. We've seen those huge excavations at the World Trade Center and elsewhere. How do you overcome that challenge?
Well, so yeah, and look, you can't. What is that expression? I shouldn't use it, right? So you can't build anywhere in New York without running afoul of some of the mass transit, right? So if you're within 75 feet of any below grade structure, it warrants a review. Look, New York's great in that the majority of the buildings that we built are founded on bedrock. So that makes it easier for us, but there is always a review. And more times than not, during the course of that review, we're modifying the foundations to really fall below what we call kind of the influence line. So, is our new building going to impart load to an existing transit structure? And if so, then we have to really lower the foundation elements kind of below that influence line, as determined by, let's say, the New York City Transit Authority. And there's a lengthy review process that can take, up to 6 months. And, Jeff and Stephen were talking about getting permits. It's another part of that entitlement process that has to be factored in. So, there's always something to run into, or the potential to run into something. So, with good planning, good scheduling, you can plan accordingly, get the approval in a timely fashion, with little impact of project schedule. So it's all about forethought.
Definitely, Jeff. Have you kind of come across that from some of the projects you've worked on as well?
Constantly. I mean, it's nearly every project that we work on has some, review required from an agency, a transit agency. So, it's de rigueur. It's sort of part of the course here in New York. And again, it's one of the intricacies of building in a really well-developed dense city with a real robust transit system. So.
And just to point out that the One Vanderbilt project is built right next to Grand Central Station. So while all this is going on, the trains are underground, and you have, hundreds of thousands of people trying to skip through your project site every day to get home and to get to work. So that makes it quite a bit challenging as well.
Yeah, that's for sure.
Absolutely. We've got room for maybe a couple more questions. We've had a really great one from an anonymous person, but they've asked. We've all spoken about the challenges, but what's been the most exciting, gratifying, and interesting project that each of you have worked on in New York? I should caveat. Stephen Bradbury, want to go first, or do you want time to think?
The most interesting one, probably not the biggest. I mean, One Vanderbilt for sure. It's a postcard project for me. But the Kosciuszko Bridge piers we did a couple years ago. That was like one of our first climbing bridge pier jobs in the New York City area for a while. So that came off pretty good. So that was a great project for Perry.
Jeff, how about you from the Walsh perspective?
Yeah, so it's an easy answer for me right now. My current job is the LaGuardia Central Terminal building redevelopment. So new 35 gate terminal in the existing space of the old terminal. We have to maintain 33 gates throughout all phases. So we got 30 million passengers coming through the airport every year, and it's been a extremely complex. We're in year 6 of 7. Extremely complex phase job, and just I'm extremely proud when I go out and see the portions of the terminal that are open. We got about a year left, and the whole vision will be realized. But it's been really exciting to see it take shape.
Stephen, D. Simone, how about yourself?
Oh wow, there's a lot of good ones. I hate to single one out, but probably recent project 220 Central Park South. It was, look, the best projects are really the projects where you're working with really engaged teams, right? Not only from the design side, but from ownership and from the construction side. So there we had, really an A-team, first-class developer in Vornado, great architectural teams, Ramza, SLCE, they're sort of stables around here in New York. Bovis was the CM, and Cross County was the concrete contractor. So it was working out and high strength mixes, looking at the workability of the mix, the use of high strength bar, form systems, how do we in ways modify the design to allow for the use of certain form systems, temporary openings to get forms from floor to floor. So it was a real coordinated effort that gave us really the ability, and I'm proud of, look, it was a great product. We got a real understanding of what the client was trying to achieve. And by every measure, the project was a super success, from sales to resales, all in just a great experience and something that we're really proud of.
It's a great choice. I agree with you. It's a fantastic project. I think it also had the most expensive New York apartment sold to date or something. I think it was over
$257 million.
Yeah.
It's only a lot of money if you don't have it. So, and the guy made $1.5 billion that year. So it was chump change. Huh?
Indeed. I'm still saving up. I'm about $257 million short, but
there's a unit with your name on it. So
you could hold it for me for like 500 years. That would be great. Rachel, from your perspective, I know perhaps not involved in the day-to-day of construction, but what's your favorite building that I guess Autodesk's been used on, or what's your favorite New York skyscraper? You can pick which question you'd like to answer.
Good question. I mean, I think the towers the new towers are absolutely incredible. So I mean, just from being up on the top of there, looking out, it's incredible. I wasn't around for the construction of it, but incredible. So
fantastic. Great to have you insight. Now, another question we've had, again, this is anonymous, I believe. Do you think there'll ever be a megatall skyscraper in New York? And for those of you that maybe don't know what megatall is, that's a building that exceeds 600 meters. I believe Central Park Tower has the highest roof line and is around 451 meters, I think. Speculative question, I know, we won't hold you to it, but do you think New York will ever go megatall?
That's a good question. Yeah, I would say we're an aspirational city, so yeah, the answer's got to be yes, right? We'll get there. And look, the buildings that we build stateside are commercially viable projects, right? I mean, they're not vanity projects. They're not, they're not something sponsored by the government, right? It's when the projects make sense. As technology improves, as materials improve, as land continues to get more and more expensive, as people move back to the cities, yeah, I think we'll get there.
I'll be skipping that site visit. I can see Stephen wanting to do the Perry formwork, but I will be. I love skyscrapers, but I'm scared of heights. So 600 meters on a Perry formwork system. I'm busy that day, but
well, we can only do it with a Perry system. So.
on that note, we're gonna have to leave it there. But guys, we've got so many fantastic questions. I think we've got over 40 questions coming. We've got through some of them. We are going to endeavour to get as many of them answered afterwards as we can. Huge thank you to everyone that's tuned in today. We really appreciate it. Massive thank you to our panel. It's been fantastic to have this discussion. I want to have this discussion for another couple of hours. It's awesome. Such an interesting subject area. So thanks to each of you for making the time, and huge thanks to Autodesk as well for working with us to make today possible. It's been awesome. There's been a few questions about whether this is going to be available on demand. It will be available on demand. You'll be able to get the link shortly afterwards. It will be emailed around to the attendees of today and those that missed out. So yeah, stay in touch. We're looking forward to seeing you all again soon. Thanks again to our panel, and thanks to everyone for watching. Have a great day. Cheers.